Sanjay Kumar. He completed his BE Civil Engineering from Madurai Kamaraj University. He also pursued his ME Soil Mechanics and Foundation Engineering from Anna University, Chennai. He worked as a designer engineer for 1 year under a structural consultant in Madurai. He is currently working as a faculty member in the Department of Civil Engineering, Tyagarajar College of Engineering, Madurai. He has organized 2 national conferences at TCE in 2010 and 2014. He's also got 3 publications in international journals. He is an A-lead member for the Geotechnical Consultancy at Tyagarajar College of Engineering.
Welcome to UGC lecture series on architecture. Name of the subject is Mechanics of Structure 1 and we are in Unit 3, which is Properties of Section. This is lecture number 9. We shall see the contents of this lecture. We will be seeing the calculation of moment of inertia of triangular section. Then we will be seeing 2 problems in moment of inertia calculation. Now, let us calculate moment of inertia for triangular section. Let us consider a triangular section ABC. Let small b be the base width of the triangular section and h be the height or altitude of this triangular section. Within this triangular section, we shall consider a small strip. Let PQ be that particular strip and the thickness of the strip be dx. Dx is the thickness of the strip. Let this strip be at a distance of x from the apex C. By applying similar triangle principle, x, the distance x divided by the height of the triangle h, x divided by h will be equal to the width of the strip PQ divided by the base width AB, which will be equal to PQ divided by base width AB is small b. Now, we can determine the width of the strip PQ. So, width of the strip PQ will be equal to small x into b divided by h. Already the thickness of the strip is dx. So, area of the strip will be equal to x b divided by small h into dx. Moment of inertia of this strip about the base AB will be equal to area of the strip. Area of the strip will be x b divided by h into dx into square of the perpendicular distance between the strip and the base AB. Now, distance between the strip and the base AB is this distance, which is equal to h minus x, which is h minus x. So, square of the perpendicular distance will be h minus x the whole square. Now, we shall calculate the moment of inertia of the whole triangular section about the base AB. Moment of inertia of the whole triangular section about the base AB will be obtained by integration. So, I am writing moment of inertia about base AB as IAB. IAB will be integral of b by h into x into h minus x the whole square dx between the limits x equal to 0 to x equal to h. Now, this b by h is a constant term, I am taking it out. So, we will be getting integral of x equal to 0 to x equal to h, x into h minus x whole square dx. If we expand this term, we will be getting x into h square minus x cube minus 2h x square dx. Now, IAB will be equal to B by H into within bracket. The first term is x h square dx, integral of x into h square dx. H square is common, so we shall take it out. So, we will be getting integral of x dx, which will be equal to x square by 2 plus the second term is minus x cube dx, integral of minus x cube dx. Upon integrating it, we will be getting minus x power 4 by 4, and the third term is minus 2 h x square dx. 2 h is constant, we shall take it out. So, integral of x square dx, which will be equal to minus 2 h into x cube by 3 upon the limits 0 to h. So, we will be getting b by h into h power 4 by 2. I am substituting the upper limit. So, instead of x square, if we put h, we will be getting h square. Already we have a h square here. So, this term will be h power 4 by 2 minus, upon substituting the upper limit here, we will be getting h power 4 by 4 minus 2 h, upon substituting the upper limit as h here, we will be getting h cube by 3 minus, if we substitute lower limit which is 0 in all the 3 terms, we will be getting once again 0. If we take the LCM and simplify this, we will be getting b h cube by 12. So, moment of inertia of a triangular section about its base AB will be equal to b h cube by 12. Now, this is the triangular section AB C. We have found out the moment of inertia of this triangular section about its base AB. Now, we need to find out the moment of inertia of this triangular section about its centroidal x-x axis. So, this x-x axis passes through the center of gravity of the triangle, and hence it will be called as centroidal x-x axis. Distance of this center of gravity from the base for a triangle will be h by 3. We have seen this already, where h is the height of the triangle, height or altitude of the triangle. Now, by using parallel axis theorem, IAB will be equal to IG, or here it is IXX plus A into h square. Now, this is according to parallel axis theorem, where IG is the moment of inertia of the triangular section about its centroidal x-x axis, which will be IXX. A is the area of the triangular section, and h is the distance between the centroidal x-x axis and the line AB, which is h by 3 here. H here it will be equal to h by 3. Now, IAB has been already found out, it is b h cube by 12, which will be equal to IXX plus A is the area of the triangle, base width of the triangle is small b. So, area of the triangle will be half into b into h, half into base into height, into this h is the distance between x-x axis and the line AB, which is equal to h by 3 here. So, h by 3 whole square. So, which will be equal to IXX plus b h cube divided by 18. So, this is b h cube by 12. Therefore, IXX will be equal to b h cube by 12 minus b h cube by 18. If we take the LCM and simplify this equation, we will be getting IXX as b h cube by 36. So, moment of inertia of a triangular section about its centroidal axis IXX, or we can call it as IG, will be equal to b h cube by 36. Moment of inertia of a triangular section about its base AB will be equal to b h cube by 12. Now, we shall see a problem for calculating the moment of inertia of a rectangular section. the dimension of the rectangular section is given. Length of the rectangular section is 10 centimeter and breadth of the rectangular section is 4 centimeter. So, this is the rectangular section with length 10 centimeter and breadth 4 centimeter. Calculate the moment of inertia of this rectangular section about its longer and shorter sides. About its longer and shorter side. Now, this is the longer side and this one is the shorter side. I am extending the longer side. The longer side is named as AB and the shorter side is named as AC. We are asked to calculate the moment of inertia of this rectangular section about AB as well as about AC. Now, this dot is the CG of this rectangular section, CG. This line represents the horizontal centroidal axis of the rectangular section, which is x axis, and the vertical line passing through the CG will be the centroidal y axis of this rectangular section. Moment of inertia of the rectangle about its centroidal x axis IXX, or here it will be IG, which will be equal to B into d cube by 12. Now, the dimension parallel to x axis is AB, which will be taken as the breadth B. So, B here will be equal to this 10 centimeter. So, 10 into the other dimension which is perpendicular to this x axis, other dimension perpendicular to x axis is 4 centimeter, will be the depth here. So, d cube will be 4 cube divided by 12. Now, we need the value of moment of inertia of this rectangular section about the longer side, which is AB. So, IAB will be equal to IG, which is equal to IXX plus area of the rectangle into square of the distance between the line AB and x axis. Now, we have computed the value of IG, which is 10 into 4 cube by 12 plus area of the rectangle A is 10 into 4, which is 40 into h square. Now, distance between x axis and the line AB, this is our h here. So, h distance will be 2. So, it will be 2 square. So, the answer will come as 213.33 centimeter power 4. Now, this is the moment of inertia of this rectangular section about its longer side AB. Similarly, we shall calculate the moment of inertia of this rectangular section about its shorter side, which is AC. IAC will be equal to, here we will have IYY plus AH square. Now, we need to get the moment of inertia of this rectangle about the shorter side AC. Centroidal axis parallel to the shorter side AC is YY axis. So, the equation will be IAC will be equal to IYY, which will be now our IG value plus AH square. IYY for this rectangular section will be the dimension parallel to the YY axis. This is the YY axis. Dimension parallel to the YY axis is 4 centimeter, which will be taken as B here for calculating IYY. The other dimension 10 centimeter will be taken as D here. So, IYY will be 4 into 10 cube by 12. So, IYY is substituted as 4 into 10 cube by 12 plus area of the rectangle is 40 into h square. H is the distance between centroidal YY axis here and the side shorter side AC. This is our h, which will be 10 centimeter by 2. So, h square will be 5 square. The final answer will be 1333.33 centimeter power 4. So, this is the moment of inertia of the rectangular section about its shorter side AC. Now we shall solve another problem. Calculate the moment of inertia of the section shown below about its centroidal x-x and y-y axis. Now, as the first step, we have to locate the center of gravity for this section. Locating the center of gravity of this given section will be done by moment area method, which we have discussed already. Now, the given section is an unsymmetrical I section, which is a combination of 3 rectangles. Now, we shall divide this I section into 3 rectangles like this by drawing lines here. So, this will be rectangle 1, this will be the second rectangle 2, and this will be the final rectangle which is numbered as 3. Now, the coordinates of the CG of this I section will be computed with reference to axis. The reference axis will be the bottommost line. So, this is the reference line and the left end line of the figure. Now, we shall calculate the value of x bar for this I section. So, center of gravity will be somewhere here. Distance of the center of gravity from the left line is x bar. So, this distance is x bar, and the distance of the center of gravity from the bottom line, this distance will be y bar. So, this distance is y bar. Now, we are going to calculate the value of x bar as well as this y bar. X bar will be a1 x1 plus a2 x2 plus a3 x3 divided by sum of all the areas a1 plus a2 plus a3. Now, a1 is the area of this first rectangle. So, this is the first rectangle, area of this first rectangle is 6 into 2, which is 12 centimeter square. x1 is the distance of CG of rectangle 1. So, this dot represents CG of rectangle 1, distance of this CG from this left end line is named as y and the bottom line is named as x. So, this is x1, distance of CG of rectangle 1 from the left end line or the y axis. So, if you see the figure, this distance will be half of 10. So, x1 is 5 centimeter. A2, area of the second rectangle will be this height of the second rectangle, will be, it is 10 centimeter as per the figure. So, it is 10 into breadth is 2, so 20 centimeter square. x2, now let this particular point be the CG of second rectangle. Distance of CG of second rectangle from left end line, that is y axis, once again here it will be same 10 by 2, which is 5 centimeter. Next, we shall calculate area A3, area of the third rectangle, which will be 10 into 2, 20 centimeter square. x3, this dot is the CG of the third rectangle, distance of the CG from left end line will be same 5 centimeter once again. So, if you do the substitution and if you do the calculation, x bar will be a1 12 into 5 plus 20 into 5 plus again a 20 into 5 divided by sum of the areas 12 plus 20 plus 20, which comes as 5 centimeter. Now, we should also calculate the value of y bar. Y bar will be a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. Now, we shall calculate the value of y1. Now, this is rectangle 1, this is the CG of rectangle 1. Distance of CG of rectangle 1 from the bottom end line, bottommost line is here x axis. Distance of this CG from the bottommost line, the total height of the I section is 2 plus 10 plus 2, 14 centimeter minus this 1 centimeter will give you the value of y1. So, y1 will be equal to 13 centimeter. Now, we shall get the value of y2. Now, this is the CG of rectangle 2, distance of the CG of rectangle 2 from bottommost line. So, this is 2 centimeter, from here to here it is 2 centimeter, then again this will be another 5 centimeter. So, y2 will be 2 plus 5, which is 7 centimeter, and y3, distance of CG of rectangle 3, this is the CG of rectangle 3, distance of CG from the base, this distance will be 2 by 1, which will be 1 centimeter. Now, y bar will be 12 into 13 plus 20 into 7 plus 20 into 1 divided by sum of the areas 12 plus 20 plus 20. So, we will be getting 6.08 centimeter. X bar is already found out as 5 centimeter. Now, we have found out the x bar and y bar value, that is x and y coordinates of the CG of the given I section. Now, let us calculate the moment of inertia of the given I section about its centroidal x and y axis. So, this is the CG of the I section. This distance is calculated as y bar. The value of y bar is 6.08 centimeter. So, this remaining distance will be 7.92 centimeter. Okay. Now, we shall calculate moment of inertia of the whole I section about its centroidal x axis. Centroidal x axis. So, this is the centroidal x axis of the whole figure, that is the whole I section. Moment of inertia of this I section about its centroidal x axis Ixx will be equal to, here we have 3 areas. We are going to apply parallel axis theorem for the 3 areas, rectangle 1, rectangle 2 and rectangle 3. So, we will be getting Ig1 plus A1 H1 square plus Ig2 plus A2 H2 square plus Ig3 plus A3 H3 square. Now, Ig1 is the moment of inertia of rectangle 1 about its own centroidal x axis. Now, this is the centroidal x axis of rectangle 1. Moment of inertia of this rectangle 1 about its own centroidal x axis will be b d cube by 12, in which b is the dimension parallel to this centroidal axis. So, this 6 centimeter will be b. So, 6 into d cube is 2 cube, depth of this rectangle 1 is 2. So, b d cube by 12 plus a1 is 12 into h1 square. H1 is the distance between centroidal x axis of rectangle 1, this is the centroidal x axis of rectangle 1 and this x axis of the overall figure. Here we have the x axis of the whole I section, distance between these two axes is h1. H1 will be 6.92 centimeter. So, into 6.92 the whole square plus Ig2 is moment of inertia of rectangle 2 about its own centroidal axis. So, this is the center of gravity or centroid of rectangle 2, this is the x axis of rectangle 2, moment of inertia of rectangle 2 about its own centroidal x axis will be b d cube by 12. Here b will be equal to this width. So, this is b. So, this width will be 2 centimeter into depth will be 10 centimeter. So, 10 cube divided by 12 plus a is 20, into h2. h2 is the distance between centroidal x axis of rectangle 2 and the x axis of the overall figure. So, this is h2. Now, h2 will be equal to, from the base, centroidal x axis of rectangle 2, that is this line will be at a distance of 2 plus this one is 5. So, it is 7 centimeter minus, from this distance if you subtract this 6.08, we will be getting the distance h2. So, 7 minus 6.08 the whole square plus Ig3, moment of inertia of rectangle 3 about its own centroidal x axis. Moment of inertia of rectangle 3 about its own centroidal x axis will be b here will be 10 into d cube, 2 cube by 12 plus a3 is 20 into h3 is distance between x axis of the third rectangle and x axis of the whole figure. So, this distance will be h3, which will be 6.08 minus 1. So, this whole square. If you do the calculation, Ixx will come as 1285.03 centimeter per 4. Likewise, if you do the calculation for the moment of inertia of the whole I section about y axis, you will be getting the result as 209.33 centimeter per 4. So, this is Ixx and this is Iyy. We shall summarize the things which we have learnt in this lecture. We have seen the calculation of moment of inertia of a triangular section about its base as well as about its centroidal x axis. We have seen 2 example problems for the calculation of moment of inertia. Students can answer the following questions. Find the moment of inertia of the given circular section about its tangent. Now, this circular section has a diameter of 5 centimeter. You are asked to calculate the moment of inertia of this circular section about its tangent. Second question is also a problem. Calculate the moment of inertia of the given section about its centroidal x and y axis. This section is an unequal angle section. Ixx and Iyy are to be calculated. With this, we have come to the end of this lecture. Thank you.
Right.